Example 8.5.1. Here we've got a graph. It looks like a quadratic graph. It might not be, but it's been called f of x. So this graph here is the graph of y equals f of x. It passes through the origin, as we can see, and the point 4, 0, and has a minimum point at 2 minus 4. We've got a sketch on separate diagrams, a couple of graphs that have been transformed. In exam questions like this, after the thing you've been asked to draw, there's often another sentence or a couple of sentences afterwards. So make sure you read the whole question before you start drawing anything. So I'm talking about this bit here. In each case, given the coordinates of the point of intersection of the graph with the x-axis and the coordinates of the stationary point as well. Make sure you read all that and then make sure you do that. So separate diagrams. We don't want to throw away marks by doing them both on the same diagram. That's a clear instruction. We've got to follow that instruction. So the first one, y equals minus f of x. Y equals minus f of x. But at the moment the graph is f of x, what would minus f of x look like? Well, remember f of x is the same as y. So minus f of x is kind of the same as minus y. So the y values on the graph are going to be multiplied by -1. Those that used to be y are now going to be minus y or negative y. This is going to be a reflection in the x-axis. So the point that used to be positive y values are now going to be negative y values, and vice versa. It'll still go through the origin. It'll still go through 4, 0. But it'll now be that shape. So it still goes through 4, 0. Still goes through the origin. Remember, I'm doing here what the question asked. Give the coordinates of the point of intersection of the graph with the x-axis and the stationary point, which was here. It used to be at 2 minus 4. It's now going to be at 2 positive 4. So there we go, that was a reflection in the x-axis. F of x becoming minus f of x. Think of that as y becoming minus y. So the values that used to be positive become negative and vice versa. So a reflection in the x-axis. On part B, y equals f of x take away 2. This is going to be a translation to the right by 2 units. Translation to the right by 2 units. So keep the same shape, but it'll now go through the x-axis at 2, 0 and 6, 0, and then the coordinates of the stationary point used to be 2 minus 4. It's moved 2 to the right, so now it'll be 4 minus 4. Now let's just take a moment to check part B, because it's a common mistake to get this going the wrong way. With the -2, you might think it would move to the left, but actually it doesn't, it moves to the right. So let's go back to our original graph, and how can we use that to check? Well, our original graph tells us by looking at, let's start off with this point here, 4, 0. That's telling us that f of 4 is 0. When x is 4, so when x is 4, y is 0. F of 4 is 0. Is that still the case on our graph? Is f of 4 still 0? Well, if we go look at this point here, 6, 0, when x is 6, put that in, x take away 2, so f of 6 take away 2 is f of 4, and yet the y-coordinate is still 0. So yeah, so that helps us to check that we've moved it in the correct direction. We can do a similar thing with the point 0, 0, or even 2 minus 4. So this point is telling us that f of 2 needs to be negative 4. Let's check that here. Sub 4 minus 4 in. If x is 4, then inside the brackets we get 4 take away 2, which is 2, and y is minus 4. Yep, we still get that relation that f of 2 is minus 4. Of course, you could also use the origin, which tells us f of 0 should equal 0. So put this point in, 2, 0, sub it in, and you get f of 2 minus 2 equals the y-coordinate, which is 0. And yet f of 0 is 0. That confirms we've definitely moved it in the right direction.